So we deal with elasticities in a number of different ways, and we will get more complicated applications of it in sophisticated pricing models of later chapters where we look at bundling goods together and using elasticities for that purpose. So this is definitely an important foundation. So formula for elasticity. Go. Tell me what it is. Got to have that off the top of your head. Elasticity of demand is what? Percentage change in quantity over the percentage change in price. So if you've got that memorized, then the rest of the formula will start to fall into place because you've got, how do we do this? We got the new number minus the old number divided by the old number, but remember now that we've got our big boy and big girl pants on, it's a point estimate. So divided by that quantity, or the new number minus the old number divided by the point estimate, the old number typically in a percentage change formula. So then if you kind of math this out, you get this change in Q over the change in P over the point estimate along the demand curve. And that's a helpful formula. Why was it helpful? What did this jump out for us? It was the slope, right? And so with our demand function, that was now the slope of one of the functions, but not all of them. All right, so conceptually, if we get out the, let's see, I'm trying to decide when to bring out the golf clubs. Let's just start with the home base situation. All right, so if we had a demand function, we could calculate the elasticity of demand at this point using this formula, right? So if I had an equation for this demand function, we could calculate the elasticity. As the demand curve gets steeper, what happens to the elasticity of demand? More inelastic, right? So remember that little cheat rule. As it becomes steeper and steeper, it starts to look more like an I for inelastic. Is one way to remember that. Same thing with the supply curve. So more elastic is flatter. And if we have a more elastic demand, what does that tell you about the availability of substitutes? There's more substitutes or less substitutes available? More. So more substitutes. You change the price on me, bam, I'm going to either buy a whole bunch more because I'll stop buying the other one that's kind of a close substitute, or you raise the price on me and bam, I'm going to start buying the other product. So more elastic, less elastic. All right, so today what we're going to focus in on is the effects that has on consumer and producer surplus when we start to impose a tax. And so now, the burden of the tax, you might remember, was dependent upon the relative elasticities. So if I make the demand curve more inelastic, then more of the tax is going to be passed along to the consumer or producer? More to the consumer. The consumer. So think about the consumer's inelastic demand. They're willing to absorb price changes. If we impose a tax on them, then they're going to pay more. However, if the supply is equally inelastic, then they might still be sharing the burden equally, right? So it's always supply elasticity relative to demand elasticity that tells us who's going to pay the burden of All right, so that's kind of where we're going today. So you need to have the elasticity formula burned into your head, both this form and this form. And then also conceptually have this in your head, the steepness or flatness of the curves. The one thing to be careful of is this slope. Is this the slope of the demand function or the inverse demand function? Inverse? Tough question. Is that the slope of the demand function or the inverse demand function? What's the slope of this line as I have things drawn on this graph? What's the slope of this? P over Q. No. Change in P over change in Q. Rise over run. Does this expression look like this expression? No, so that should trigger right away. Is this the inverse demand curve or the demand curve? Inverse. It's the inverse demand curve. So we draw this function in this space, putting a P on the vertical axis and a Q down here. That's the inverse demand curve. And so for the elasticity formula, an important distinction here is that that is not the slope of the inverse demand, but rather the slope of the demand function, where the Q's on the left-hand side of the equal sign rather than the P. All right, so that kind of sets the stage for us to get into our next problem. Any questions on that? Yeah, Jesse.
On the, you said that's the inverse. Okay, does that matter? Like, are we going to have to switch things?
Yes, you might have to. Conceptually, it's important to look at which one you're dealing with. We're going to work through some problems as why today, but just remember that when we draw the one that we were used to in principles class, to match up our graphing goggles with our equation goggles, that means it's P is some function of Q. And if we just say a slope-intercept form, it's this, right? So we've got the Q on the right-hand side of the equation, the P on the left. That's the inverse demand function. That's the one we've always drawn in principles class. The demand function is switching this around so that the Q is over here, and we get A plus BP. And this B now is the change in Q over the change in P. So the slope of this, in this functional form, which we call the demand function, not the inverse demand function, the slope of this function is change in Q over change in P, which is that.
Is that like the slope of the supply curve?
No, this is all demand. So this is the slope of the demand, and I'm getting a little bit sloppy here. I could put a QD. This is the quantity demanded as a function of price. And over here, this is price as a function. We've got price on the left-hand side of the equation, quantity on the right.
So that change in P over change in Q is the inverse demand slope?
Yes,
Okay.
that's right. Which is just fall back to rise over run. When you're doing it graphically, fall back to rise over run. But otherwise, if you've got your equation goggles on, then you're putting it into slope-intercept form, and you can have the P over here, the Q over here, whatever it is, the slope of it is that B factor right there. Okay?
Could you graph it the same way if they just gave you the equation for QS?
Depends. You would not ever graph it in this space with P up here and Q down here, but in mathematical terms, there's nothing wrong with doing this, and then your slope number would be whatever that function looks like. But we don't do that typically, so that's not something you'd want to do. You'd keep it in the inverse demand space. So all your graphs in your book, anytime we look at something graphical related to the market system, we put the P up here. But there is going to be a reason why we do it that we'll see today of talking about it both ways. So open up take out your worksheets. Has everybody got their copies from? I'm not sure if I've got extra one. I got one extra one. Maybe this is. We're going to work on. We're going make sure I give you the right one. Otherwise, you're just going to have to write it down, Adam. So we did the consumer surplus one with that demand and supply. I want to do we're going to do the local tire market one, I think, first. And I can let you use this. So this is the one that has a local tire market with a demand function 3,200 minus 25p and a quantity supplied equal to 15p minus 800. So there's your supply function, your demand function. Does everybody find that handout? Okay. So go. A local tire market is represented by the following equations, where Q is the number of tires sold weekly and P is the price per tire. The equilibrium price per tire is 100, and there's 700 tires are sold each week. So suppose that an improvement in technology of tire production makes them cheaper to produce, so that sellers are willing to sell more tires at every price. Specifically, suppose that the quantity supplied rises by 200 at each price. This is similar to the problem we worked through before, at least the first part of the problem is. What's your approach? Set them equal to each other?
Yeah.
You can, and that would be the right step to take if we weren't given the equilibrium. So let's just assume that they got the right, that they gave us good information. So we're jumping to the next step, I guess is what I'm saying. So we've got equilibrium price and quantity.
So if you just want to take the quantity supply equation and add 200?
Good, yep, do it. Minus 600. Yep. So you're adding 200 units. So the story as you read the equation is to say, here's how they used to behave. Now they're going to add 200 tires to every quantity that they used to supply. So we're just simply, think of it this way, adding 200 to this side. What we used to do plus 200 is simply that plus 200. And now solve out your new equilibriums. As soon as you get an answer, let me hear what it is. $95. So we do that by setting the new quantity, or the old quantity demanded equal to the new quantity supplied. Let's call that QD0 QDS. And that leads to a price of 95. You guys keep working it out if you're not there yet. I want you to, that's part of what we're doing is for you to work through it. Don't just copy down the answers. And you had a quantity of 825. Did everybody get there? 95, yep, you got it. Start bringing a calculator. I don't have one. You got your phone? I'll let you use your phone as a calculator if you want. As long as it's silenced. Oh, you have an extra one? Okay, Taylor's got an extra one. The mathematics major comes prepared with 2 calculators.